Hello everyone, welcome to the first long-form video of the Project Formula YouTube channel. Today we're going to be going over a lot of foundational concepts that you need to know to get an A in your class in Algebra 1 that are confusing to a lot of students. This is part 1 of 2 of this series. Today I'm going to be going over linear equations, inequalities, and functions. Next week I'll be going over nonlinear functions like quadratics, exponential functions, and absolute value, for example. But for now, subscribe, like, send this to your friend who is absolutely cooked for tomorrow's exam, because this is going to clear up a lot of foundational concepts that you need to know for any of your tests. So first we're going to be going over algebraic manipulation. Here's an equation. 2x plus 6 equals 12. How do you solve for x in this equation? We've gone over this in one of the shorts or Instagram reels if you've seen those. These are pretty simple. In these types of equations, all you need to do is isolate the variable. So you can do any operation to one side, like addition, subtraction, multiplication, or division, as long as you do it to the other side as well. So first, we're going to go in the opposite order of PEMDAS. You might have heard of that: parentheses, exponents, multiplication, division, addition, subtraction. We're going to go in the opposite order because we're solving for x. So first we'll do subtraction, subtract 6 from both sides to get 2x equals 6, and then we'll divide both sides by 2 to get x equals 3, and that's our answer right there. That's pretty simple. Let's move on to something that we haven't really covered. Let's try going over some word problems. So 2 consecutive numbers add up to 23, find the smaller number. Now, these types of word problems, all you really have to do is take the words that they're telling you and convert them into numbers and variables, because that's the only way you're going to be able to do it. Trying to brute force it like 1 plus 2 equals 3, 2 plus 3 equals 4, well, it can't be those. Won't work, because ultimately you'll find yourself working with bigger and bigger numbers like 600 or something. So we know that 2 consecutive numbers add up to 23. Let's label the first one x. So x is the smaller number and y is the bigger number. We know that these two numbers add up to 23, so x plus y equals 23, and the smaller and bigger number are consecutive, which means that one comes right after the other. So y is the bigger number equals x plus 1. So for example, if x was 2, then y would be 3. If x was 5, then y would be 6. Now that we have 2 equations, we can do one of the principles for solving for 2 equations, like substitution or elimination, that we've learned about in other videos, some of my short form content, if you want to go check those out. So here, I think the best way to do this is using substitution by substituting this value into y over here. So we get x plus 1 equals 23. Simplify, 2x plus 1 equals 23. And then just solve, subtract 1, 2x equals 22, divide both sides by 2 to get x equals 11. And then we plug that back into one of the original equations to get y equals 12, and those are our numbers. The smaller number is x equals 11. Next, we're going to move on to something pretty foundational to a lot of algebra problems. Sometimes these questions won't involve y. Instead they'll use something called f of x. Now, f of x is a function, or f is a function. What this basically means is any equation, I guess, is a function as long as for every x value there's only one y value. So for example, in a slope-intercept equation, y equals mx plus b, this is also a function, like f of x equals mx plus b, because let's say m is 1 and b is 0. This line would just look like this, and this is a function because for every x value that you plug in, there's always just going to be one y value. Like for x equals 4, y will be 4. For x equals 3, y will be 3. Now, there's different notation for all of this. So, for example, if you have f of x equals x cubed minus 1, you can say f of 4 is what? Well, here, we're just plugging in 4 for x. So f of 4 is 4 cubed minus 1. 4 cubed is, you can do this in a calculator, 64, minus 1 is 63. And that's our answer. Or maybe they'll ask you, what's the value of x when f of x equals something else? Again, f of x is basically y in most equations, so they're basically just giving you a y value and asking you to solve for x. So, for example, what value makes f of x equal to 63? Well, we obviously just did that, but 63 equals x cubed minus 1, add 1 to both sides, 64 equals x cubed, take the cube root of both sides to get x equals 4. And that's our answer. Now, there's also more function stuff like, for example, they won't give you a number to plug in for f of x, but they'll just give you another variable or another version of that variable. So for example, f of a, again, for functions, it can work for any variable. It doesn't have to be x. So f of a equals 8a plus 5. But I do want to note, if it does say f of a equals 8x, and then it says, what's f of 4? That's not 32. Not necessarily, because a is not always equal to x. You do want to know that, because sometimes they will try to trick you. But f of a equals 8a plus 5, a question could ask, what's f of 2a? And here, we're still just plugging 2a in for a, so we get 8 times 2a plus 5 equals 16a plus 5, and that's our answer. Let's talk about translating these functions. So, for example, here's a graph, f of x equals, let's do 3x plus 5. So this is a line. We've gone over slope-intercept. If you don't know what that is, we'll go over it later also. But our slope here is 3 and our y-intercept is 5. A question could ask, what is the equation for this graph shifted 5 units upward? Now, when we're shifting up and down, all we really need to do is just add the amount that it's asking us to shift to the end of the original equation. So if it's asking us to shift 5 units up, we just take f of x equals 3x plus 5, which is obviously 10, and that shifts it up. Now, it does look like it's shifted to the left also because it is, but it also is shifted up. Or it could ask us to shift it down, in which case we would subtract 5, and this is also shifted down. For shifting it left or right, it becomes a little bit more complicated with different equations like quadratics or exponentials, which I will go over later, but for now, it is easier to know because you just have to subtract or add like the opposite way. So if that's confusing, all that means is just that if you're going right, you have to subtract 5 from x. If you're going left, you have to add 5 to x. So you saw that when we added 5, it shifted left, and when we subtract 5, it shifts right. Then there's also stuff like composite functions. So they might give you two functions, like f of x equals 4 plus x, and then maybe the other function won't be labeled f, because this is a separate function, but they'll label it g of x. This is still a function, it's just a different variable, just like how x and a are different variables, or x or y are different variables. So g of x equals 3x plus 2. And they might ask you to substitute f of x into g of x. So what that means is the equation might ask you what's g of f of x. And we saw earlier for the example with f of 2a, all we're doing is still substituting. So we take our g of x equation and we substitute 4 plus x for x. So we get 3 times 4 plus x plus 2. We simplify this to get 12 plus 3x plus 2, and then we simplify this to get 3x plus 14, and that's our answer. And then I think that's it for functions, or maybe for composite functions they may ask you to set it equal to something else, like what we did for f of x equals x cubed minus 1, we set f of x equal to 63 and we solved. But it's ultimately the same thing. Let's move on to linear equations. Now, we've gone over substitution and elimination in some of the short form content that I've put out, but we're also going to go over it here, just in case you haven't watched those videos, though I highly recommend you do because it goes over them with different equations that will help you situate those concepts in your mind better. But let's do the equations x plus y equals 21, and 3y equals, or actually let's do 3y plus 12 equals x. So let's use substitution for this one. We have x by itself already, but we don't really know what it is because it's in terms of another variable, y. So what we're going to do is we're going to substitute this x into this equation. So we get 3y plus 12 plus y equals 21. This is x, by the way. And now all we have to do is solve. So we get 4y plus 12 equals 21. And we just solve this like normal. 4y equals 9. Y equals 9 over 4. And then that's only one variable, so we have to plug this back into one of our other equations, like this one. So x plus 9 over 4 equals 21. We subtract 9 over 4 from both sides, and we get x equals, to simplify this, we have to turn this into an improper fraction. So 21 times 4 over 4, which is 84 over 4, minus 9 over 4, which gets us 75 over 4. Now let's talk about elimination. In these types of equations, what we're doing is making a variable disappear like so. So we will take 3x plus 4y equals 21, and then negative 3x minus 2y equals 2. Now, here we can eliminate the x variable by simply adding these equations together. So we get 2y equals 23. Now, why can we do that? Well, think about it this way. 3x plus 4y equals 21. In this equation, we're going to add 2 to both sides to get 3x plus 4y plus 2 equals 23. Now we just take the 2 here and substitute it for the negative 3x minus 2y that we find here in one of our original equations to get 3x plus 4y minus 3x minus 2y equals 23. Our 3x's and negative 3x cancel, and then we simplify 4y minus 2y to get 2y, which is equal to 23. And then y equals 23 over 3, or 23 over 2, sorry. Now that we have one variable, it becomes easy. We just substitute this back into one of our other original equations, and we get x. I'm not going to do that right now because we just did that with a substitution problem. But here's a harder elimination problem because sometimes they will give you stuff like this. For substitution also, I'll do one of those first actually. So 3x plus y equals 7, and then 4y equals 3, no, let's not do 3, 7x plus 9. Now here there's no apparent substitution or elimination thing, but we can manipulate the equation. So let's take 3x plus y equals 7. We can subtract y from both sides to get Actually, I think it's better to subtract 3x from both sides, because that instantly gets us y by itself by giving us y equals 7 minus 3x, and then we just substitute that into one of our other original equation and do the same thing. For elimination, sometimes it'll be like 4x equals, actually 4x plus 9y equals 3, and then negative 2x plus 4y equals 7. Now, again, there's no apparent substitution here, but like we've been doing over and over again, we can manipulate these equations. So we're going to multiply this equation, both sides of it, by 2, so that we get negative 4x plus 8y equals 14. Again, we can do any operation to one side as long as we do it to the other side as well. Now, we can get rid of this. And now, again, all we have to do is add these equations together to get 17y equals 17, y equals 1. Substitute that back in. I won't do that right now because you know how to do that. Let's move on. We're still going to stay on linear equations, but there's other things about linear equations, like sometimes an equation or a question will ask you to solve for y in terms of x. I think I mentioned that earlier, but maybe it'll be like 3y plus x equals 7. And all it's asking you to do is basically just get to y by itself, which we've been doing when we solve equations, except in those, we get a number. Here, we'll get something with an x in it. So we subtract x from both sides to get 3y equals 7 minus x, and then we divide both sides by 3 to get y equals 7 minus x over 3. And that's our answer. It's as simple as that. I think that's it for linear equations. So next, we're going to go on to slope and graphing these equations. I think I went over slope-intercept form in a short form video, but I'm going to go over it again. So we have y equals mx plus b is our slope-intercept form. So basically, m is the slope of the line, so the change in y value over the change in x. A more simple way of remembering that is rise over run. Because really what it is our rise, which is one of our y values minus another one of our y values to get the change in y value over, we'll label those y2 and y1, over one of our x values minus another one of our x values to get our change in x. And I did this because this is actually the formula for finding slope. So for example, let's take this equation. Actually, you know what it is. 6x, or negative 6x plus 5, or plus 4. Here, you're given this point. That's worse than I thought. Let's say you're given, this is a bad equation actually. Let's say negative 1/2 x plus 4. So here, you're given this point, negative 2, 5, and you're given, we'll label that, negative 2, 5, and you're given 2, 3. So here, what you have to do is try and find the slope of the line. Now, obviously you saw it, but we're just doing this for demonstration purposes. So we have our y2, we'll label our second point 2, 3, and our first point negative 2, 5. So we have 2, 3 is our second, and negative 2, 5 is our first. So y2 is the y value of the second point, which is 3, minus y1, which is the y value of the first point, so 5, over the x value of the second point, which is 2, minus the x value of the first point, which is negative 2. This obviously simplifies to 4, 2 plus 2, so like that. So it's negative 2 over 4, which is negative 1/2, which is, in fact, the slope of the line here. Now there's also the y-intercept. What's b? Well, that's just what y is when x equals 0. So in this equation, this point is 0, 4, x is 0, y equals 4, the y-intercept is 4. Easy as that. Then you've gone over slope-intercept. Sometimes it'll give you an equation and ask you to find the slope, like y minus 5 equals 5x minus 15. And here you just add 5 to both sides of the equation to get y equals 5x minus 20. Nope, y equals 5x minus 10. And, well, you knew the slope already is 5, but maybe it'll ask you to find the y-intercept, which is now negative 10. That's it. There's also properties of slopes. So y equals, with two different lines, y equals 7x plus 10 and y equals 7x plus 3. These are parallel lines, which means they never intersect at all. No matter what x value you plug in, they will never be the same. So if we plot them, we get y equals 7x plus 10, y equals 7x plus 3. They are parallel. They will never intersect. I can go down to negative 1500 and zoom in here. Now they look the same, but that's just because it's pretty zoomed out. But actually, if you zoom in, you'll see that they are still not the same, even at negative 1500. way you know if a line is parallel is if the slopes are the same, but the y-intercepts are different. Another thing a question might ask you to find is the slope of the line to one that is perpendicular to that line. Now, perpendicular just means that they intersect at a 90-degree angle, which is like, for example, a square has 90-degree angles. It's like perfectly upright. Now, the way you find a perpendicular slope to a line is, let's take the equation that we had before, y equals 7x plus 10. It's the opposite and reciprocal. So y equals negative 1/7 x plus 10. The y-intercept actually doesn't matter. In these types of equations, it could be like y equals negative 1/7 x minus 1000, and it would still be perpendicular. The only thing that matters is the slope. So if we graph these equations, negative 1/7 x, you'll see that looks pretty perpendicular. It looks like a 90-degree angle. And finally, for slope, there's another form that some Algebra 1 classes like to talk about, which is called point slope form. Now, the way that you write point slope form is basically y2 minus y1, or actually I guess y minus y1 equals m times x minus x1. So this x1 and y1 is a point, and m is a slope that we've gone over already. So if we had 2, 5 as our point and negative 3 as our slope, we can plug these into point slope form to get y minus y1, 5 equals negative 3 times x minus x1, 2. And that is our line in point slope form. A question might use point slope form to ask you to solve for the slope using 2 points. So for example, 2, 5 and 3, 7. Instead of using y minus y1, we would use y2 minus y1 equals m times x2 minus x1. But you know that already because it's just the formula for slope. So y2 minus y1 equals m times x2 minus x1. Divide both sides by x2 minus x1, and you just get the formula for slope that we have already gone over, which is why I really like using or slope-intercept form more than point slope, because it tells us a lot more about the graph. Let's quickly go over proportions, because this is something that some questions will talk about for solving for variables that you might just not know how to do. But here's a word problem first. Jake is going on a road trip with all his friends. He realizes that every inch on his map represents 5 miles in the real world. If the road trip spans 65 miles, how many inches is that on the map? So we know that 5 miles on the map equals 1 inch. Oh, I actually did that wrong. 5 miles just in real life is 1 inch on the map. What's 65 miles on the map? Well, we know that 5 miles equals 1 inch on the map, so 65 divided by 5 is 13 inches on the map. That's it. A lot of questions to solve, you might need to use something called cross multiplication. So 7 over x equals 10 over 4. How do you solve this equation? Well, all you have to do is multiply these terms. Make a cross, multiply those terms. 10x equals 7 times 4. We start using a dot in algebra to signify times because x is a very common variable. So we get 10x equals 28, x equals 28 over 10, which maybe you simplify to get 14 over 5. But that's our answer. Finally, I think the last thing that we're going to go over in this video is inequalities. So you know what an inequality is. It's just something is less than something else. But when applied to variables, it becomes really not that much difference, actually. Let's take an example problem. 6x plus 32 is less than 44. Now, in this question, it's asking you to find what the maximum value of x could be that satisfies this equation. So obviously, x cannot be like equal to 8, because 6 times 8 plus 32 is more than 44, not less than. Well, I don't want to brute force this, because that would take a lot of time that I don't really want to spend. So instead, we just solve it like normally. We'll subtract 32 from both sides. Comically slow subtraction, my stylus died. I'm not going to draw this anymore. 6x is less than 44 minus 32, which is 12. Divide both sides by 6 to get x is less than 2. So the maximum value will not be 2, because that would give us 44 is less than 44, which is not true. It would be 1.999999999. Like the closest value to 2 that we get without getting 2. If it asks you for an integer value, what that means is just a whole number, so 1, 2, 3, 4, 5, something like that. It would just be 1. Note that some questions will contain a sign like this. What this just means is, let's say x is this to 7. This is not just x is less than 7, it is x is less than or equal to 7, which means that x could be equal to 7, obviously. So 2x is less than 7, x is less than, 2x is less than or equal to 7, x is less than or equal to 7 over 2. So putting in 7 over 2 for x in the original equation would satisfy this equation. There's also compound inequalities. What that means is that there's three different sides of the inequality. So negative 2 is less than 3x minus 5, which is less than 4. And it might ask you to find all the possible integers or values x could be. Now here, you don't just add 5 to two sides of the equation. Obviously, you just add it to all three. So you get plus 5, plus 5, plus 5. 3 is less than 3x, which is less than 9. Then you divide everything by 3, divide by 3, divide by 3, divide by 3, to get 1 is less than x is less than 3. And that's our answer. So if it asks you what's the only integer that satisfies this value, your answer would be 2. It can't be 1 because it says x is greater than 1, not equal to 1. It can't be 3 because it says x is less than 3, not equal to 3. The only integer within these parameters, or between 1 and 3, is 2. You can also graph inequalities. So let's go back over to our graphing tool. We'll take 3x plus 5. 3x plus 5 is greater than 18. So here, it just tells us all of the possible x values that it could be. You can also use like slope-intercept or point-slope form. Like y is greater than 3x plus 5. This will give us the line y equals 3x plus 5, but then shade in everything that would make this equation true, every point. So for example, the point negative 2, 1, right there, would satisfy this equation, because if you plugged in negative 2 for x and plugged in 1 for y, you would get a true equation. Because, for example, plugging it in, we get negative 1 on the side with the x and 1 on the side with the y, so 1 is greater than negative 1, which is true. This dotted line just means that these the points on these lines are not included because it is less than. So, for example, if it was less than or equal to, or greater than or equal to, it would be a bold line. It would not be a dotted line, because, for example, this point, 0, 5, is included in this equation. It does work. If you plug in 0 for x and 5 for y, that's true. But if you plug in anything that's not shaded, it doesn't work. If this goes back to greater than and not greater than or equal to, if you plug in 0 for x and 5 for y, it doesn't work anymore. You would get, like, I think 5 is greater than 5, which is not true. I think that's all I'm going over for this video. Thank you for watching.